How does configurational entropy impact entropy of mixing? Imagine pouring different colored liquids into a glass and watching them swirl together. What makes this process happen naturally? It all comes down to how particles arrange themselves. When we talk about entropy, we're really talking about how disorganized or random a system is. Now, the part called configurational entropy is about how many different ways particles can be arranged in space. Before mixing, particles of each substance are usually packed in an ordered way. When you mix them, those particles spread out and can be arranged in many more ways. This increase in possible arrangements is what we call an increase in configurational entropy. Think of it like having more options for how to shuffle a deck of cards. The more ways you can shuffle, the more random and disordered the deck becomes. The total entropy of mixing depends a lot on this configurational part. When two substances are combined, the number of microstates, those tiny, specific arrangements, goes up. This means the system becomes more disordered overall. The more ways particles can be arranged, the higher the entropy of the system. This increase makes the mixing process more likely to happen spontaneously because nature prefers states of higher entropy. In practical terms, gases and liquids tend to mix because their particles can occupy many different positions after mixing. This increase in the number of arrangements boosts the overall entropy. It's like the particles are happier when they have more options to spread out and be in different places. So, the impact of configurational entropy on the entropy of mixing is all about counting how many new arrangements become possible when different particles come together. The more arrangements, the greater the increase in entropy. This increase helps explain why mixing happens naturally and why systems tend to move toward states of higher disorder. It's a simple but powerful idea that shows how particles love to spread out and explore all their possible configurations.